Alright everybody, previously you learned how to set up a hypothesis test by defining the random variable as well as setting up the hypothesis. Okay, today what we're gonna do is we're gonna learn how to find certain values to help us to come to a conclusion for the test that we are carrying out. So let us take a look at this section here where we will be looking at what we call the critical region as well as critical values. Okay, so what exactly is the critical region? Another name for the critical region is the rejection region. So as the name suggests, it is a region where I will reject something. Okay, what am I rejecting? I am actually rejecting the null hypothesis. That means our H0. So this rejection region or critical region, it actually depends on a particular value called the significance level. And it also depends on the type of test that we are carrying out, whether is it a left tail test or a right tail test or a two tail test. Okay, and these regions, clearly there are boundaries, right? These boundaries are what we call the critical values. Okay, so let's take a look at an example here where X is the random variable that denotes the mass of a man in Singapore, and mu is the population mean mass of men in Singapore. So in this case here, our X follows a normal distribution. Okay, if X is normally distributed, it also means that X bar is normally distributed. So our hypothesis here is the fact that mu is equals to 75 kg. All right, and we're gonna do a test to see whether is the mean population mean 75 or is it more than 75. Okay, and our test statistic is X bar, and we are given that the significance level here is 5%, okay, or 0.05. So what does this 5% mean? It actually gives me a probability. Okay, it gives me the area of the critical region, the probability. All right, and then like we said previously, the boundary is what we call the critical value. So to understand this better, let us take a look at the normal curve that we have here. Okay, so this is my X bar, the normal curve for X bar. Just now we know that our mean is 75, right? So which means that your normal curve here, the center is at 75. Okay, and also our H1 is a right tail test. So that means that my critical region is on the right hand side. So as you can see here in the diagram, the shaded region is what we call the critical region. Alright, so this shaded region is my critical region, and the area of this region is the significance level, which is 5%. Okay, so what we need to do is, now that I know what is my critical region or where is my critical region, the next thing that I need to do is I need to find the critical value that is related to this region, which is the boundary here. Okay, so to find this value, we use our GC, we use the function of inverse norm. So if you go into inverse norm, our area that you need to key in here will be the significance level 5%. Okay, then mu is our population mean 75, sigma is the variance that we have, so you square root 80 over 100. Alright, and in this case my area is on the right hand side, so you will choose right for the tail. So once you enter this, you will get a value here, right? This value is what we call the critical value. Sometimes we will write it as, in this case is X bar C. Sometimes when we use the standard normal random variable, we will write it as ZC. Okay, but basically this is the boundary value, is the boundary of the critical region. So as you can see, here we are 76.471. Okay, so we want to carry out a test. We have our critical region. what is happening here is now we do a comparison between the X bar that we have found, which is 77.2, and we compare this with the critical value that we have obtained using the significance level. So if you do the comparison, as you can see, if you can't see here, you can actually see it on the number line that you have here for X bar. Okay, so you can see that 77.2 is on the right of 76.471. So it's bigger, and in fact it is lying in the critical region. Therefore, our conclusion will be to reject H0. Okay.